Okay, so if you are happy with equations like this, equations of a line, and you're happy with equations like that, equation of a parabola, well, these all fall into a particular kind. These are called polynomials. I'll draw a few more so you get an idea of what they look like. Let's make this up. Let's do minus x cubed plus 2x, and that's it. Let's do another one. Minus 407x to the 8th plus 3. So these are all polynomials, and the general form of a polynomial is a function. We could be using y, we could be using f of x, which can be written in the form of some coefficient. I don't really like this term, some number out front. We call it a sub n to tell it from other a's. X to the nth power, where n is an integer, like 1, 2, 3, 4, 5, 83, 612. It can be any integer. And then there's possibly lower powers. If this is x to the third, there could be an x2. So there could be a to the n, one lower, x to the n minus 1. And these could keep going down. We don't know what n is in this general form, so we'll just leave it blank. And then go down to, say, a to the 2 x squared plus a to the 1 x plus a to the 0 x to the 0 is 1. So this is a general form of a polynomial. Alright, some things you won't see in a polynomial. Still a valid function. You won't see x's to the square root power. This is not a polynomial. Alright. You won't see them to the cube root power. You will not see x's in the denominator. These are rational functions. They are not polynomials. They don't fit in this form. They're valid functions, but they're not polynomials. The lines you've been dealing with, the parabolas you've been dealing with, are polynomials. So why do we bother naming these things? And we're going to be talking about we call this highest power the degree. So the degree of a line, this line, and any line, is 1. The reason we talk about this is you can tell a lot about what an equation looks like, what it's doing, just by recognizing its form, what kind of polynomial it is, by recognizing its degree. It tells you a lot about the equation. Alright, let's take a look at this. Again, these are just equations. You can plug numbers in and multiply them out and see what you get. Let's start with a line. Pick a boring one. Y equals x. I'll make it plus 2 so it doesn't go through. That's kind of it. So when we draw these things, we put arrows on the ends, which means they keep going forever. I'm going to draw another line. You'll recognize this one too. Alright, so this one goes to infinity that way and minus infinity that way. If there's a negative sign out front, there's a negative slope. And it goes to infinity in the negative direction, and it goes to minus infinity. Great. Alright, let's talk about y equals x squared. Parabola. Alright, we know parabolas look like this. They have arrows, they keep going, they go to infinity that way, and they go into infinity that way. unless the parabola has a negative sign on the x squared term. There could be other things added here. In that case, I'll pretend there's other stuff added in. So it goes through a different vertex. This goes to minus infinity that way, and minus infinity this way. So here you can look at it. If it's degree 1, it goes to infinity and minus infinity if it's positive, and the other way around if it's negative. Same thing here. Similarly, these go to both positive infinity if it's positive, if it's degree 2, and both negative if it's a negative sign. So if you just know the degree and the sign, turns out you can understand what the limit behavior, the end behavior is. This is called the end behavior. I'm not going to write out behavior. Might end up using the British spelling. Alright, so how about degree 3? Notice this doesn't turn anywhere. Lines don't turn, they're lines. Parabolas have one turning point. Alright. So degree 2 has one turning point. Degree 1 has 0 turning points. Degree 3, here's a degree 3, it's a cubic. The way I drew it here, it has a something else in it. We'll make it this. It's a polynomial degree 3 because its largest power is 3. It goes to infinity one way and minus infinity the other way if this is positive. If it's minus x cubed, it goes the other way. This one, if it's just that, it's going to do this. It's going to come and flatten out and then go like that. Alright, so let's say the axis is here. I don't know, that means something's added on here. So just if it's a degree 3, we can just look at the largest power and tell that it goes to infinity that way, minus infinity that way. Similar with degree 1. And indeed, if it's an odd degree, that's the rule. And positive, this is called a coefficient in front. This really has a minus 1 multiplied out here. This coefficient is minus 1. I don't really like the term coefficient. We don't really need a term. Just say the number multiplying the largest power. And positive, alright, then I will actually say, because we're doing the definition. Positive coefficient, then it goes to, as x goes to infinity, y goes to infinity, and as x goes to minus infinity, y goes to minus infinity. Alright, if it's a negative coefficient, and still an odd degree, then it does the opposite. As x goes to infinity, y goes to minus infinity. That's this case, or this case. That's the end behavior. I won't write it down. So we can tell a lot by equation just by looking at this part here. We can tell what happens in the end. What happens is, as you put in larger x's, this cubic term gets bigger much faster and sort of dwarfs anything here. So what happens at the end only depends on the largest term. Okay, also notice this has 2 turning points. This one has none. It doesn't turn. It flattens out, but then it's always decreasing. It doesn't turn anywhere. This is increasing, then decreasing, and increasing. It has 2 turning points. Alright, so a degree 3 has a maximum of 2 turning points. Alright, so you can probably see the rules emerging here. And we can probably guess what a degree 4 is going to look like. These problems are going to be very easy because you're going to be just looking at these things and telling what happens. Degree 4 is going to be similar to degree 2. If it has an even degree and a positive coefficient, then it goes off to infinity. This is the rule for even powers, even degrees. So degree 4 equation would be like 14x to the 4th plus 3x cubed plus smaller powers of x. That would be a degree 4 one. It goes that way. It goes off to positive infinity in both directions. Positive x and negative x. And how many turning points might it have? Well, it certainly is going to have one turning point if it's going to do that. But it can have at most 3 turning points. So it can be, it doesn't have to be symmetric. It can look like that. So it can also have, that's the most turning points it has. This has a turning point here, here, and here. You can see it's decreasing here, increasing, decreasing, increasing. It turned 3 times. Alright, so that's it for polynomials. That's the nice thing about polynomials. You can just look at them, look at the highest power, and you can tell what this is going to look like. Degree 5. Also, if this was negative x to the 4th minus x to the 4th, then it would go off to infinity in the negative direction, just like a negative x squared, like a negative parabola. Alright, this could look like. It also could flatten out, have only one turning point. This is another valid degree 4 equation. It only has one turning point. It only turns here. So the number of turning points is, say, it has a maximum of 3. Doesn't mean it has 3. It can have only one. Alright, so degree 5. That's even, so it could have at most 4 turning points. Let's see, 1, 2, 3, 4. Notice these will kind of line up. I mean, they will match up, so this is possibly an x to the 5th equation. What if it was minus x to the 5th? Or minus 30x to the 5th? Well, then you know it goes down that way. It goes up that way. And again, 4, probably 1, 2, 3, 4. Okay? That's all there is to these. So you can tell a lot about an equation just by, if it's a polynomial, its degree tells you how many turning points, and if it's even or odd, you can tell what its end behavior is. Alright, one other thing. Sometimes polynomials will not be written in this nice form of a sub n is just like 3 x to the n. N could be 4 here. So these are just, whoops. So if you have 3x to the 4th, maybe that's your polynomial. In this case, n is 4, a sub n, just showing you how these things line up, is 3. Alright, so that's how it fits into the general equation. You could have it factored out though. X plus 2, x minus 2, x plus 7. And then maybe just x by itself. This thing here does not look like polynomial, but if you multiply everything through, which is unpleasant, because you're going to start to get a lot of terms. You'll get 3 terms out of this, and then maybe 6, 5. You have to add them back together. That's not so bad. But this is going to be a polynomial of degree. Your largest x term is going to be, take the largest x from each factor and multiply them together. There's an x here, 2, 3, 4. So this is going to be x to the 4th plus something. So this is a degree 4, so you can just look at this and say, this is going to be positive x to the 4th. There's no coefficient on these, which is kind of nice. So we know this goes to positive infinity in both directions, and it has at most 3 turning points. 4 minus 1 is 3 turning points. So it's the big W of x to the 4th. Alright, so just knowing the degree tells you a lot about this equation. It may look like this. You don't have to multiply it out to really see what it's going to look like. Even if it's in this factored form, you can look at it and take the highest x power and see what it's going to look like. Alright, so we'll have a couple problems on that, recognizing these things. And remember, they're just functions. You can put numbers in, you can put it into your graphing calculator, and you'll see what it looks like. You can just graph out points. If you're ever in a test and you panic because you don't know how to do a problem, in panic mode, just plug in points. Okay, these are all you just put in points and it will show you what it's doing.